used to solve a problem, right? Used to solve a problem. So the algorithm design technique examples are brute force, divide and conquer, dynamic programming, greedy technique, etc. So in the previous classes, we discussed about brute force. Today's class, we are going to discuss about divide and conquer methodology. Divide and conquer methodology. Okay. So this divide and conquer methodology is nothing but divide the program into subprograms. Okay, or divide the problem subproblems. Okay. Conquer is nothing but combining. Conquer is nothing but combining the programs, subproblems. Okay. So this divide and conquer algorithm works by breaking down the problem into two or more subproblem on the same type, right? This is called as divide. Conquer is the problem, that subproblem can be solved easily. Finally, combining the subproblem is called as conquer. Okay. So the steps of divide and conquer is problem is divided into several subproblems of same type. So the subproblems can be solved individually. Finally, combining the solutions of the subproblem to get the original problem. I'll explain the steps with a listen. So now this is the problem of size n. Okay, the main problem. So the problem is divided into n by 2, n by 2, right? Division. This is divide. Next, first two steps are division. Okay, the solution to get the final step is combining all the solutions to get the original problem, right? These are the steps of dynamic programming. Okay, steps of divide and conquer. Clear? So the first two steps related to divide. The next two steps are conquer. Next, the divide and conquer methodology can be easily applied on the following problems, such as merge sort, quick sort, and binary search. Merge sort, quick sort, and binary search. Okay, next. The first sorting type is merge sort. We can apply divide and conquer in merge sort. Okay, so this merge sort is based on the divide and conquer technique, right? So initially, all the values are divided into two sub problems, right? Two divisions. Okay. Next, solving the subdivisions. Finally, merging the sorted divisions to get the original problem, right? Let me explain the example first. See, this is the example. Initially, we have input elements 83297154. Okay. This is the input. Input is divided into 8329. Another part is 7154. Two parts. Okay. Now again divide 8329 into 29. 7154 into 7154. Clear? Again divide 83 into 8, 3, 29 into 2, 71 into 7 and 1, 54 into 5 and 4. Okay. So the first steps up to this divide steps. Okay. Up to the divide steps. The next step is combine, conquer. Okay. That is called as what? Conquer. Now sort 3 and 8. That is 3, 8. Sort 2, 9. Sort 7 and 1. Answer is sorted is 1, 7. Sort 5 and 4. Sorted is 4, 5. Okay. Next, again sort 3829 into 2389. Okay. 1745. Divide 1745 into 1457. Right. Combine finally Combine the sorted into 1, 2, 3, 4, 5, 7, 8, 9. Clear everyone? So this is called as what? Merge sort. This is called as merge sort. Okay. Next. Okay. This is called as merge sort. So we have two pseudocodes to solve merge sort. The first, any doubts in merge sort example? So first part is divide. The next part is conquer. Okay. Any doubts, ma? Any doubts in this example? Any doubts? Okay, next is students. Any doubts, ma? Am I audible? Students, am I audible? Any doubts?
Yes.
Okay, next are the two algorithms. Two algorithms in merge sort. So merge sort is based on divide and conquer technique, right? So we have two pseudocodes. First pseudocode is to divide. Another one is to combine. Okay. Initially, the keyword algorithm. Name of the algorithm is merge sort, within bracket the array. Okay. Array from 0 to the last element is n minus 1. Okay. Now we are going to sort this array by recursive merge sort. Okay. Input is an array A of 0 to n minus 1 unsorted elements. Output is array 0 to n minus 1 of sorted elements. Okay. Now consider n is greater than 1. Value of n is greater than 1, which means n represents number of elements in the array. Okay. N represents number of elements in the array. Now the number of elements are greater than. Now copy the first of elements to B array. Okay. Copy the first of elements to B array. Next copy the second of elements to C array. Okay. Let me explain you clearly. Consider the array 70, 20, 30, 40, 10, 50, 60. Okay. One more element 90. Okay. Now this is called as A. Okay. Now copy the first of elements to B array. Okay. So copy to B equivalent to 20, 30, 40. Okay. Next is copy the second half elements to next array, that is 10, 50, 60 and 90. Okay, ma? As per the pseudocode, n by 2 minus 1. So that is first element is 0. The last element is n. Okay. First element is 0. The last element is n, right? So this middle element is what? N by 2. Okay. Consider this 10 is n by 2. N divided by 2. Okay. The middle element is n. Now The previous two middle element is what? N by 2 minus 1. Clear everyone? N by 2 minus 1. Or I'll write it separately. Initial element is N. Last element is, initial element is 0. The last element is N. Okay. Now, the middle element is N divided by 2. Okay. N divided by 2. So the previous element is N by 2 minus 1. Okay, ma. What is the next element? N by 2 plus 1. Okay, clear everyone? Now, copy the first of elements, that is 0 to N by 2 minus 1 in B array. Next set of elements to C array. Okay. Next set of elements to C array. Clear everyone? This is called as what? Merge sort. Next, first copy the first half elements to B array. Next, copy the second half elements to C array. Okay. Finally, merge this B, C into A array. Okay. Finally, merge B, C into A array. This is called as the first step. Okay, ma. So first is the large array, single array 83297154, right? This single array is divided into two arrays such as B array and C array, right? Now the B array is 8329, C array is 7154. Clear everyone? Again, divide this 8329 into 83 and 29. So this 8329 array is called as B array. This 2389 is the B sorted array. 2389 is the B sorted array. The 7154 is the C array. This 1457 is the sorted array. Okay, 1457 is the sorted array. Okay, now this up to this 2389 B array, 1457 C array is the first pseudocode. Right, this is the first pseudocode, right? Next, see the next pseudocode is to combine. Okay, combine. Name of the first pseudocode is merge sort. Next, now the name is merge. The inputs are two sorted arrays. Okay, two sorted arrays B, C. The two sorted arrays are B and C. Okay. Finally, two sorted arrays are B and C. Combine the values of B and C into the A array. Okay, A array. This algorithm merges two sorted arrays into one single, one sorted array, capital A. Okay. Now, what are the inputs of this? Inputs to this second pseudocode? Two arrays B and C. Okay, two arrays B and C. Output is the sorted array A of the elements B and C. Okay, initially combine I equivalent to 0, J equivalent to 0, 0. Okay, so now I, J and 0, right? Now the condition is we need to check two conditions. The first condition is while I less than P and J less, okay. Next, do if condition satisfied, again check B of I is less than or equivalent to C of J, right? If condition satisfied, assign P of I to A of K and increment the value of I equivalent to I plus 1. Okay, A of K equivalent to C of J, value of J and K will be incremented, right? If I is equal, copy the C array to A. The B array, A array. Clear? This is the second pseudocode. Now I'll teach you the pseudocode with an iterations, right? Okay. Now consider the example. Now consider the example. Example value 70, 20, 30, 40, 10, 50 and 60. Okay. 70, 20, 30, 40, 10, 50 and 60. Now, initially tell me the division, ma. How to divide this elements. Consider the first element is 0. The last element is n. Okay. So which is the n by 2 element? What is n by 2 element? Which is the n by 2? N by 2 is, students reply me, n by 2 is, anyone is on the line? What is n by 2? Reply me. Students, are you listening the class? Reply me, ma. Students, are you clear? Is it clear? Any doubts in math sort? Any doubts? Students, any doubts? Okay. Why you are all silent? Okay. Now consider the input elements 70, 20, 30, 40, 50, 60. Okay. Now the zero is the zero element is the first element 70, n is the last element 60. Okay. Now divide this n by 2 is the middle element, n by 2. Okay. N divided by 2 is 40. N by 2 is 40, middle element, right? So now we can divide 7, 20, 30 as the B array. Okay. This is the B array. Next, C array is 40, 10, 50 and 60. Okay. C. Now, again we can divide 70, 20 and 30, right? Here we can divide 40, 10 and 50, 60. Okay. Now again we can divide 20, 70, 20, 30. Okay. Here we can divide 40 individual elements, 10, 50, 60, right? Now we can combine 20 and 70, 20. Here we can combine 10 and 40, 50, right? Finally, we can combine 20, 30, 70. Here 10, 40, 50, 60, right? The final A array is equal to 20, 30, 10, right? Starts from 10, 10, 20, 30, 40, 50, 60 and 70. Okay, I'll explain you more detail in the table. First 3 elements, Okay, first 70, 20, 30. Next element is 10, 50 and 60. Okay, now divide the first divided into 2 and one single value, that is 10. Next divide into 20 and 20. So this is 70, 20, 30. This is 40, 10. Next 50 and 60. Okay. Next is divide the values into single values. Okay, single values. The first value was 70. Next is 20. Students, is it clear? 30. Here it is 40, 10, 50 and 60. Okay. Next, again insert first two to sort 70 and 20. Now we are going to sort 20 and 70. Next, this is 30. Okay. Here it is 20, 40. Here it is 50 and 60. Okay. Now combine. Here combine 3. This is 20, 30, 70. 20, 40, 50 and 60. Okay. Finally combine this two array into a single array. Okay. The final value was 10, 30, 40, 50, next 60 and 70. Okay, ma, this is the final merge sort. Okay. Now we are going to do the iterations. Consider the same example. Consider the pseudocode. So we applied the divide and conquer methodology in merge sort, right? The first part is divide and the next part is called as what? Combine, right? That is called. Now we are going to discuss the pseudocode with an iteration. Okay, iteration. Now consider the codings. Consider the pseudocode. Now this is the pseudocode. Okay. Our example is 10, 20, 30, 40, 50, 60 up to 70. Okay. In the pseudocode initially, I equivalent to 0, j equivalent to 0 and k equivalent to 0, right? I equivalent to 0, j equivalent to 0, k equivalent to 0. Next, the condition is while before that, one more thing. So in the input is sorted array of B and C, right? Input is sorted B and C array. Okay. So now the sorted array is, this is the B array. Two inputs. Now the sorted B array 20, 30, 70. Okay. This is the B array. This is the B array. Sorted B array 30, 70, 20, 30 and 70. Okay. Next, sorted C array. What is the sorted C array? Students, what is the sorted C array? Twenty, 30, 70, 10, 40, 50 and 60. Okay, 10, 40, 50, 60, right? This is the C array. Here, this in the B array, the first, consider the first value as I, right? And the last, the C array, the first value is J, right? First value is I. In the B array, 0 to P minus 1, P, right? Okay. In the B array, first value is I. C array, first value is J, right? K is the output. Okay, K is the output array. K is the pointer in output array. K is output array A. Output array. Okay. Initially, I equivalent to 0 in the pseudocode. I equivalent to 0, J equivalent to 0, K equivalent to 0, right? P nothing but number of elements V is one array, P equivalent to elements in number of elements in B array. Okay, number of elements in B array. Okay, PQ. Then what about Q? Q is the number of elements in C array. Elements in C array. Okay. Number of elements in B array, number of elements in C array. Okay. Now, I equivalent to 0, J equivalent to 0, K equivalent to 0. Now, what is the value of P? P equivalent to 3. Okay. What is the value of Q? Q equivalent to 4. Right? P equivalent to 3, Q equivalent to 4. P represents number of elements in B array, Q represents number of elements in C array. Okay. Now, in the pseudocode, what is the condition? What is the while loop in the pseudocode? I is in 0th position. Okay. Index is 0. A of 0. Okay. A of 0. A of 0. Next, A of 1. A, right? Now, R B array. This is B. Okay, B array. Name of the array is B of 2. Next, this is C array. So C of 0. C of 1. Three. Now, 10, 40, 50, 60. 40, 50, 60. I equivalent to 0, J equivalent to 0, K equivalent to 0, right? While in the pseudocode, I less than P, right? I less than, I is 0, right? 0th index. Initially, I is in 0th index. So 0, number of elements 3, and initially J is in 0th index. 0, or initially I equivalent to this one. I equivalent to 0, J equivalent to 0. 0 less than Q is number of elements in the C array 4. Now both conditions are satisfied. Okay, both conditions are satisfied. Now A of K, initially K equivalent to 0, right? A of K, K equivalent to 0. A of 0 equivalent to B of, initially B of I is 0, I equivalent to 0. Okay, ma. Now what is A of 0? A of 0 is nothing but your output. Okay, this output array. This is output array K, right? So initially K is in 0th position, K. Now assign B of 0 to A of K, right? Now A of 0 equivalent to B of 5. Now the value of I will be incremented. I equivalent to I plus 1, that is 0 plus 1, 1. I equivalent to 1. Okay, else we missed one condition, that is if P of 0 is less than or equivalent to C of 0, right? What is B of 0? What is B of 0? What is B of 0 element? What is B of 0 element?
20.
20. C of 0 element is
10.
10. Okay. Now condition not satisfied. Okay, condition false. If condition satisfied, we have to increment the value of I. This is B array. This is C array. This is output array. Now this condition is not satisfied. Okay, if condition is satisfied, assign B of I to AK, I equivalent to I plus 1. So now the condition false. Condition false, else part will be executed. Okay, else part will be executed. Else part will be executed. Okay, what is the else part? A of K, A of K equivalent to C of J, right? Now A of K is A of 0, C of J is C of A of 0, C of J equivalent to J equivalent to J plus 1, that is 0 plus 1, 1. Okay, 0 plus 1, 1. Also K equivalent to K plus 1, that is 1. Okay, ma? Now the condition, I deleted this if statement. So if statement is B of 0 less than or equivalent to C of 0. B of 0 was B of 0 was, what is the element? B of 0, 20. And this is 10. Okay. Now condition not satisfied. The else part will be executed, right? Now assign C of 0 to A of 0. Okay. Now what is C of 0 value? What is C of 0?
10.
10. Okay. So listen, this is the output array 10. This is the output array 10. This is the output array A. Okay, output array A. Okay, ma. J equivalent to 1, K equivalent to 1. Now, if I equivalent to P, okay, that is the final step. If I equivalent to P, copy the C array to A array, else copy the B array to C array. Now check if I is 0, I equivalent to 0, equal, what is I equivalent to P? What is the value of P? Number of elements in the B array, right? This is false. Next, iteration 1. Okay, easy dama, konja time eduthuko, right? But it's very easy. Iteration 1. Next, now tell me the iteration 2. Lenient to write. Okay. Okay. This is iteration 1. Next, iteration 2. Students, now tell me iteration 2. Now, iteration 2. In iteration 2, what is the value of J and I, J and K? What is the value? Students, tell me what is the value of I, J and K? I remains 0, right? I remains 0. I remains 0. J equivalent to 1. K equivalent to 1. Okay, that's all. What is the condition? While, what is the value of I? I is 0, less than, what is the value of P is 3, and the value of J is J equivalent to 1, less than value of Q is 4. Okay. Now the while condition is satisfied. What is the if loop? If is P of, anyone is there on the line? Tell this if statement. If B of, what is the value of phi? B of phi is, students, what is B of phi? What is B of phi? Students, what is B of phi? I equivalent to 0. B of 0 less than or equivalent to C of 1. Now what is B of 0? What is B of 0?
20.
20.
30, 30. 20 down.
Right, I'll copy down. This is C array, B array, this is the output array. B array, C array. Okay. Now B of 0 is 20. B of 0, 20. C of 1, 40. Okay. B of 0, 20. B of C 40. Now condition satisfied. Okay. Condition satisfied. Condition true. What is the next statement? Now the condition is satisfied. A of k is 1, right? A of k is 1. A of k equivalent to B of 0. B of 0, right? Now, what is B of 0? So we are going to assign B of 0, that is 20, to A of 1 element. We are going to assign 20 to A of 1. Listen, the first in the output array, the first position is A of 0. We already inserted 10 and A of 0 from the first iteration. Next is A of 1, A of 2, A of 3, A of 4, A of 5, next A of 6. Okay. Now we are going to assign 20 in A of 1, 20. Okay, ma? So what is the next step? Assign this and I equivalent to I plus 1. Okay, I equivalent to, what is I plus 1? I equivalent to 1, right? I equivalent to 0 plus 1, that is 1. Okay, that's all. Now tell me iteration 3 quickly. Iteration 3. It's time up. Iteration 3. So in this fashion, you have to complete all the iterations, right? If condition is false, condition not satisfied, the else part will be executed, right? If condition not satisfied, the else part will be executed. Called as what? Merge sort. Iteration 3. Iteration 3, I equivalent to 1. What about j? J equivalent to 1. K equivalent to 1. Okay. Now condition is while 1 less than 3 and 2 less than 3. 4. Not 2. 1 less than 4. Okay. Next, your condition is if, what is the condition? B of I is 1. B of 1 less than or equivalent to C of J also 1. Okay. What is B of 1? What is the element stored in B of 1? 30. What is C of 1? Okay, ma. Now condition satisfied. Condition true. What happens now? Condition satisfied. Now assign. Okay. Here I and J will be incremented, right? I and K. Listen pannanga. This K is common to two statements. This K is two statements. Okay. I equivalent to 1 and K equivalent to 2. K will be incremented. In iteration 3, K equivalent to 2. Now condition true, A of 2 equivalent to B of 1. Okay. Now what is B of 1? B of 1 is 30, right? 30 will be stored in the output array, right? A of 2 equivalent to 3. Now increment the value of I, right? That is I plus 1, 2. One more thing, increment the value of k plus 1, 2 plus 1, 3. Clear? Students, any doubts in these iterations? You try to complete all the iterations, right? Try to complete all the iterations. In the next class, I'll teach you the analysis of merge sort. Okay? Students, any doubts in merge sort? So this merge sort is one of the algorithm design techniques, right? Under divide and conquer. Okay. Okay, ma. Thank you all. Thank you, students.
Yes.